Hello, hello. It's time for some more math help. We got homework 3.3 up in here. This time, the homework 3.3 is majority of it is about finding the slope. So we're going to see some problems about that in a little minute. And let's get started. Before we get to the slope problems, we got some problems about determining if a set of points is linear or not. Now, one thing you could do, it's not the best, but you could graph it and see if it forms a straight line. Problem is sometimes stuff that's like almost straight kind of looks like it is. So let me show you what I'm talking about. Let's see if it happens on any of these problems. So on Desmos, if you want to make a table like these ones here, you simply click the plus sign and click on the word table. These points that are laid out horizontally here, you can turn those into a table. So -2, -3, -1, -7, 0, -11, 1, -15. Okay, then you want to observe the graph. Do they form a straight line? Now that looks pretty close, and you could check it is. Like what you're looking for is, does it go the same amount down and over, basically, or is it in a pattern that would go down and over? So to go from the first point to the second, it goes down 4 over 1, down 4 over 1, down 4 over 1. So since it's repeating that does make it linear. I will say this, though. Instead, you could just consider this. Look at the x values. These keep changing up by 1. The y values keep going down by 4. That's why it was down 4 from the y values over 1 because of the x values. So you don't actually have to graph it. I'm just suggesting that a graph could help you visually inspect to make sure that it's linear or not. The problem is if this was -16, it would still look pretty linear. You know, I guess now that you've seen the one that was right, this one does look a little bit weird, but maybe looking at this might look linear at first glance too. So I'm just saying, be careful of that. Okay, we'll combine that for now. Okay, so this is linear. Now, I'm not gonna try that hard on all these problems. What I'm looking for is a pattern. So are the x values increasing the same and are the y values increasing the same? Like that last problem. So 2, 6, 10, 14. Those are all going up by 4. I'm looking at the x values. 2, 6, 10, 14. How about the y values? -1 to 3 is an increase of 4. 3 to 8 is an increase of 5. And 8 to 15 is an increase of 7. So that's not good. Now, here's the thing. Sometimes different increases in y is okay because maybe the x values proportionally changed as well. That would make it linear. However, right here, if the x values are being constantly changed and the y values are not being constantly changed, then it's definitely going to be not linear. And that's how all these problems are. I'm not saying you're going to encounter that nice of a situation in real math doing, but in these problems, yes. So 1, 2, 3, 4, those all go up by 1. Down 3, up 2. So the last one like screws the whole thing up, not linear. This is up 4, up 4, up 4. And then all these are 2, which doesn't look good at first glance. Probably somebody would look at that and go, "Oh, wait a second, that can't be right. Can they all be 2?" Yeah, they can all be 2. This is up 0, up 0, up 0. So yeah, that's consistent. So if you ever see all constant y values or all constant x values, that actually should be linear no matter what. So if you're seeing that, you know, that's the thing. Alright, another one. For each function, linear or not linear. Okay, so 3, 7, 11, 15, those x values are all going up by 4. And then 5, 4, 3, 2, those are all going up by 1, so linear. -1, 0, 1, 2, okay, those are going up by 1. And then the y values are 4, 4, 4, 4, 4, so linear. Because not changing y values is actually okay. Okay, here x values go up by 3, up by 3, up by 3, down by 1, down by 2, down by 4. A cool pattern, but no, not linear. Let's see, 2, 2, 2, down 4, down 4, down 4. So that's how you determine on these ones. Alright, next, find the slope of a line passing through the points -8, -3, and -3, 4. Now here's the deal on these problems. You should do it by hand. I'm gonna do one by hand, and then I'm gonna show you. I'm not saying I'm gonna use Desmos to like do it some cheesy way. I'm just gonna use Desmos to do the work after these problems. So let me open Paint real quick. All right, open that right over there. Get my writing board out here. Alright, so we're going to do, so here's the formula we're using. We're using y2 minus y1 over x2 minus x1. Now here's my advice, is normally you should label these. I'd put, under the 8, negative 8, I'd put x1, and then under the negative 3, after the 8, I'd put y1, and then for the second set, I'd put an x2 and y2. That way it really helps you like label stuff. My other advice is this, when you're doing it by hand, is write the bar out with a minus sign on the top and the bottom. Yes, those are minus signs. Sorry, they're pretty fat minus signs. Okay, but then you fill it in. So y2 is 4, y1 is negative 3, x2 is negative 3, x1 is negative 8. So here's why I pre-filled out the minus signs, because they need to be in the equation. They're part of the formula, essentially, to find the slope. Even if I'm plugging in other things that are negative, I should put those in there. And then if there are two negatives, like I had twice here, this would become 4 plus 3, because that's what two negatives do, is the minus minus is really just adding. And negative 3 plus 8. So on the top I'd get 7, and on the bottom I'd get 5. And yes, the answer doesn't need to be a whole number. I mean, it could be a whole number. It doesn't need to be a positive number. It doesn't need to be a proper fraction. This is an improper fraction. 7/5. That's an acceptable answer. I think it's an acceptable answer. Okay, now let me show you two things. Number one, if you want to try and do this on Desmos, what you could do is this. So hold on, let me set up some Desmos stuff here for you. What you could do on Desmos is you can literally plot points. If you go on Desmos and type in points like this, they'll put the points on the graph. Let me zoom it in a little bit here. Hold up. Okay, so here's the points on the graph, right? And then what you can do is you can just count the rise and the run. So from the first point to the second point, it goes up 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3, 4, 5. 7/5, just like that. So you can totally do that. There's a couple things you got to keep in mind. The first point always needs to be the left point, not necessarily the higher or lower. So from left to right, how do you get from the left point to the right point? And then the second thing you got to keep in mind is, let's say I zoom out like this. Now it looks like it's going up 1/2, 1, 2, 3. See how this is like weirdly zoomed? So you got to make sure it's zoomed in a way that each individual number is accounted for. Like, see, even here, this looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That wasn't the case, right? Now, what you can do is, if you do zoom in a weird way, you will get some kind of situation like this one where I have gotten like 14 over 10. Is 14 over 10 the answer? Yes, it's just these are doubled if I do it like this. So, I mean, and this isn't me counting correctly anyways. I was just showing a point. So I'm just saying, be careful of doing that, okay? My advice is this: if you're going to use Desmos, use it for this. Like, see this thing right here that I wrote? That's what I'd want you to do in Desmos. 4 minus negative 3, all divided by negative 3 minus 8. It can do the math for you, and you're probably like, hey, look at that. What is that? Oh, wait a second. Forgot the extra minus sign. You're probably like, okay, what is that? What does that equal? You can click this, and it'll tell you 7/5. So I'm just saying, if you want to do the work, on Desmos, that's fine. I loved seeing the setup for this. That's obviously a good idea. But from henceforth, I will be using Desmos to set up, okay? Alright, passing through these points. So I'll set it up. y2, 9, minus y1, 3. You'll notice I'm selecting all before I hit divide because that puts it all over. And then x2, 5, minus negative 3. 0.75, which is 3/4. So as long as you know how to set up the problem, like here's my main issue. If your math isn't great at doing this kind of stuff, that's okay. Like, I'm okay with you use a calculator or whatever. Just you need to know the setup. That's the key. That's the key idea. Find the slope of the line passing through these points. So I'm going to do y2 minus y1 all over x2 minus x1. I got 0. Now I need you to keep in mind the reason why we're getting 0 here is because the top has 8 minus 8. So if you have something on the top that cancels out and makes 0, 0 on the top, the answer is 0. Now let's compare that to the second problem of this. Negative 2, I don't need to print these. Negative 2 minus 1, those are the y values. And then negative 4 minus negative 4. And it says undefined. Yeah, that's correct. So the answer is undefined. There's a button over here, undefined. Now keep that in mind. The undefined is caused because the bottom stuff cancels out to make 0. This makes 0. The top doesn't make 0. The bottom makes 0. So when the top makes 0, you're getting a slope of 0. When the bottom makes 0, you're getting undefined. Another one. Probably two more of the same thing. No, never mind. Alright, find the slope of the line passing through these points. Okay, so same old, same old. Negative 7 minus 8. Those are the y values. 5 minus negative 7. And simplify, negative 5/4. So what I would have got doing it by hand, guys. So if you're feeling like this is a little cheesy, I mean, yeah, this is exactly what I would have written doing it by hand. I would have got negative 15 on top, 12 on bottom, and negative 15 twelfths reduces to 5/4. So, I mean, it's just saving you some headache of simplifying. Find the slope of the line passing through these points. Oopsies. Regular 4 minus... Now, wait a second. I got to point something out. Every time I've done this, I keep using the second point to start. You don't have to do that. You could do first minus second, as long as you make sure to do it both. Like, for example, if I do negative 3 minus 4, and I do negative 8 minus negative 3, I get 1.4, so I get an answer of 7/5. That's a flashback from earlier. But let's say I did it reverse. What if I did 4 minus negative 3 all over negative 3 minus negative 8. Oh, look, the same exact answer. So it really doesn't matter if you use the first set in front of each row or the second set in front of each row. It gives you the same result. So don't feel like you're going to mess something up if you don't do it exactly a certain way. There's two ways it can go. The thing you don't want to do is you don't want to reverse. Like, you don't want to do 3, 4, and then do negative 3, 8 on the bottom. That would reverse the bottom, and that does make different answers. So you can't just do whatever you want, but there's at least a couple options you could do, right? Oh, this looks like those earlier ones with the zeros, but let's check it out. We got negative 7 minus 6 over 9 minus 9. Okay, so that's undefined. One thing you can do is, like, I'm not saying you shouldn't show work or whatever, or at least try it. However, I am going to say that the answer to these should be obvious if you're looking carefully. See how it says 9 and 9 for the x values? That immediately tells me the bottom of the fraction is going to become 0. If the x values are ever the same, the bottom will become 0, and therefore it's undefined. On the other hand, if you look at the y values being the same, that tells me the top of the fraction is going to be 0, and automatically this will be 0. But just for the sake of showing you that that isn't the case, I'll still plug it in. I mean, it never hurts to try stuff, you know what I mean? See? Made 0. Alright, these next couple problems say what kind of line is it? So what you're looking at is as it goes from left to right, what's happening. So on this first one, it's going up as it goes from left to right. That's a positive slope. However, if the line's going straight up and down, well, now you've gone too far and you've become undefined. A flat slope is a slope of 0. The reason why is because, remember when we talk about slope, we're talking about rise over run? Well, how much rise does this have? 0. How much run does it have? A lot. So it's 0 over a lot equals 0. On the other hand, the rise here is a lot, and the run is 0. So this is something divided by 0, which is undefined, which is why earlier when we were doing the problems, dividing by 0 is undefined. Okay, last one is going down as it goes right, so that's a negative slope. So going up to the right is positive, down to the right, negative, flat, 0, undefined, up. This is in the notes, so refer to them, please. Alright, the points this and that lie on a line with the slope of 4. Find the missing coordinate r. Uh-oh, I'm thinking about sneezing. Hold up. I hope you didn't hear that. I muted the mic, so hopefully that works. Alright, anyways. I'm not gonna use Desmos. I'm gonna be a legitimate guy and use Paint here for a second again. Yes, the second best product to use on the computer when doing math. Okay, so here's what you want to do. You want to set it up. Set it up like normal. You know, put your little bar, put the little minus signs, and then fill it in. y2 minus y1. Now, in this case, y1 is the letter r. x2, negative 3. x1, negative 6. And then usually you're using this to find the slope. However, in this problem, we know what the slope is going to equal. It's going to equal 4. So this is the setup here. You need to make sure that part of the writing of the equation has some stuff to represent the y and x values, and then it equals the slope that is known. Now what you're going to do is you're going to solve this little equation here for r. So what we get is we get 13 minus r on the top we get negative 3 plus 6 on the bottom. So 13 minus r over 3 equals 4. So we're going to solve that guy, right? That guy right there. I mean, this teeny little button right here. All right, so I haven't solved the problem yet. I just have 13 minus r over 3 equals 4. Now, your r might be on the bottom of the fraction. Your r might be first, and then the number, like 13 or something, might go second. It varies, you know what I mean? But you're probably going to get, you're definitely going to get r or x or some letter somewhere in the fraction here equal to some sort of slope. And the slope could be a whole number. It could be not a whole number. It could be a fraction. If you get a fraction, I recommend cross-multiplying. In my case, I just have all this over 3. Should I still cross-multiply? I'll still cross-multiply. This will work for everyone's problem this way. So cross-multiply. So if this isn't a fraction, make it 1. And then I'm going to do stuff. I'm going to do 13 times 4. I mean 3 times 4. I'm going to write that up here. I hope you guys don't mind. Boop. So that gives me 12. And then 1 times this stuff. Now 1 times anything is itself, so I'm just going to write 13 minus r. Whoop-de-doo. Okay, now we solve. I minus 13 on both sides. Remember, our goal is to get r alone. So I get negative 1 equals negative r. And then if you divide by negative 1 on both sides, you get regular 1 equals regular r. Now could you solve that using some Desmos or something? Of course, I want you to show your work and all, but I will show you on Desmos. The secret on Desmos is, though, you have to know how to set up the equation. So let me close this out here. So let me show you. On Desmos, if I was doing this, I would do exactly like I normally do. I'd write y2, y2, 13, minus y1. Now, I could type r, but Desmos gets a little mad. So if you have a variable, you're going to have to use x. So 13 minus x over negative 3 minus negative 6. Okay, it graphs this. This isn't correct at all. You have to set it equal to the slope, so equals 4. And then what it does is it graphs a vertical line through what will be the solution, 1. So the thing is, you can do this. You have to know how to set it up, though. Like the math here is, do you understand this concept of slope well enough to know that you need to set up the equation in this certain way? Now, you're supposed to be able to know how to solve it, too, so I sure hope you do, but this is one way to know how to solve it, I guess. Okay, problem 11. A bucket's being filled with water. The graph below shows the height as the bucket is filled in seconds. Okay, great. How much does the height of the water increase for each second the water is running? Which is a very fancy way of saying, as you go over 1 second in time, how much height of water has there been an increase of? Well, this one's so convenient. Look, it starts at 0, 0, and then as you go over 1, the height increases to 6. So each second the water is running, the height increases by 6 millimeters. What is the slope of this line? Well, the slope of the line is the rise over the run, and didn't it rise 6 and run 1? It's 6 also. So what they're trying to show you in these problems is that the slope of the line is the simple way of saying something, but in context of a word problem, it could mean more. So this one means the slope in this case is 6, and that also means in the case of water filling the bucket, every second of time causes 6 millimeters of height increase in the water. That's the whole concept of slope. When we're talking about graphs and slope, I hope I described this well in class. Graphs and slope. So when you're talking about graphing something like y equals mx plus b, the question is, how does y change based on what you plug in for x? So when you plug in something for x, what's happening to y? So depending on the slope, it causes different amounts of change. That's what the slope is. The amount of change that happens when you increase x by 1 or some amount or something like that. And then also there's plus b, and that just represents the starting value. In this case, the starting value was 0, which was very convenient. I'm thinking the next problem won't be at 0. Well, look at that. It's not at 0. Okay, they're adding water to a pond. The graph shows the amount of water in the pond in liters versus the time in hours. Another time. You're going to find time a lot in word problems. Okay, so time and water in the pond. So here you got to be careful. If you go over 1, the height is 1,000, but the slope is definitely not 1,000 because it didn't go from 0 to 1,000 like the last problem went from 0 to 6. This one goes from 600, the starting value, to 1,000. So the increase here is it goes up 400 and over 1. So the slope is 400. Now, it's not always so easy to find the slope by going over 1 or whatever. Sometimes you won't be able to see like a nice whole number. What if this didn't cross at 1,000? What if it was like a slightly weird thing and then only at number 2 did you see something, reasonable? So you might need to do something over 2 and reduce it. In this case, up 400 and over 1, pretty straightforward, adds 400 liters per hour. 400 liters per each hour. Every time you wait 1 hour, 400 more liters in the pond. Slope of the line, 400. And there you go. Submit assignment. Alright, it's done. Elapsed time 85 hours and 26 minutes. Darn, took forever. I can't believe it. That was because I opened it on, I don't know, Thursday or Friday or something, and then I didn't get to finish it. But I did now on a Sunday, so here it is. 3.3. If you see this before the due date, good job. If you see it after the due date, well, it still has good information. It's going to help you, study for a quiz or whatever you're eventually going to see. Hopefully that helps, and I am out of here. Thank you very much.